So we're talking about the triangle proportionality theorem, which can also be called the side splitter theorem. And so it is when you have a line that's parallel to a side and it cuts the sides proportionally. So if a line is parallel to one side of the triangle, then it divides them proportionally. Okay. So our last unit we talked about the mid-segment theorem. So mid-segment theorem, they were parallel as well, but it was in the middle, it was the mid-segment. So it split the sides into two equal pieces. This one isn't necessarily in the middle, so it just splits them proportionally. So what you have to do when you're setting up the proportions is decide if you're looking at a whole side or a piece of a side. So like if we look at number 1, we want to complete the proportion. So we have EF. So if I look over here, here's EF. And it has EF over FG. Well, are EF and FG entire sides or pieces of sides? Pieces of sides. So then the next one, BA, would match AG. Question on that one. Okay, let's look at our next one. So our next one we have CB. So CB is here. And BA. So again, are those whole sides or pieces of sides? Pieces. So then it says question mark is to EF. So EF is here. So which piece matches CB? BE. You got it. Question on that. Okay. So let's look at our next one. Our next one we have EB. And we have FA. Are those whole sides or pieces? Whole sides. Good. So they are whole sides. They aren't cut up. So now if I'm looking at my next one is FG. FG is the whole side of this tiny triangle. So if I'm looking, I have this tiny triangle FA and FG. So if I have this second one EB, the whole side of EB is EG. Okay. So I had the whole side of EB. So EB is like this middle triangle. So EBG right here. So this middle triangle. So if I look at my tiny triangle, I have FA and FG. So then FG matches the whole middle side EG. Questions on that? Okay. Let's look at our next one then. So our next one is EG. So EG again is the side of this middle triangle. And then I have ED, which is this one. And then I have something to CB. Okay. BG, good. So I have DE and CB matching. So now I need EG matches BG. Good. Alright, let's look at 5. So 5 I have DC, which is this whole side down here. And it's matching FA, which is this little guy. And then I've got something is to AG, which is this one. So again, this one is different because DC and FA are the entire side length of the triangle. Okay? So I need the entire side. I have the entire side of the little one, but the entire side of the big one is this whole thing, CG. Question on that one. Okay. So then our last one, we have GF, which is this tiny side. And we have FA, which is this small side. And then my next one, I have GD, which is this whole side. So I know that GD would match this FG. So then which one would match the little one FA? Good. This whole thing down here, DC. Very good. So you have to decide, am I looking at pieces of the sides or am I looking at whole sides? And this one's strange because they're all three together, but usually they're split like our next ones. But questions? Which part? Yeah, you're just matching. So like if we pulled these, let's look at this last one. If we pulled these apart, so let's say this is our big triangle, and it's D, C, G. And then we have the little triangle, F, G, A. So now we've got GF, which is this guy, over FA, which is this one. Then we have GD. What? Oh, sorry, I flipped them. D's up here. See. So then I have DG, which is this whole side. Well, this whole side matches this whole side. So then this little side matches this DC. Yeah. It's just because they're together, which makes it strange. Right. Yeah. Yeah. Any other questions on these 6? Okay. And so, again, we're not looking for them, like for the sides to be equal. We're looking for the proportions to be equal. So let's look at our first one. So number 7 says, given that PQ is parallel to BC. So these two are parallel. That's what those little arrows mean. We want to find X. Now, again, you can set these proportions up so many different ways. There's literally like one way you set it up that will be wrong. So if you want to, when you have the sides just go here and here, you can set it up that way. So you can say 8 over X equals 12 over 18. You could also say 8 over 12 equals X over 18. You could flip them and say it the other way. The only thing you don't want to do is like cross diagonally. So you would never say 12 over X and 8 over 18. But that's pretty much the only thing the only way you don't want to set it up. And now it's just a proportion like what we did yesterday. So we just cross multiply. So 8 times 18 and 12 times X. So we get 144 equals 12X. Good, and then we just divide. So X equals 12. Yay. Questions? So then 8, we do the same thing. We just go boom, boom. So 33 over X equals 27 over 18. And this one doesn't tell me that they're parallel, but it has the little arrows, so I can assume that they are. And then again, we just cross multiply. So 33 times 18 gives us 594 equals 27X. And what's my next step? Yep. So we divide by 27. And so we get x equals what? Good. 22. Perfect. Any questions on this? And so, of course, you can have some like what we did yesterday where it's more than x, where it's like x plus 3 or x plus 4. And those you solve the same way. There's not many of them, but a couple. Alright, let's look at the last one. So the last ones, we don't know that they're parallel. We want to know if they're parallel. So if they are parallel, then that means the sides are going to be proportional. So we just want to see if they're equal like what we did yesterday. So if we split them, we could say 8 over 15, and we want to know, does that equal 5 over 11? So if we do 8 over 15, we get 0.53 repeating, but then 5 over 11 is 0.45 repeating. So then it would be no. So they are not parallel. Like, how would you know if you didn't do the math? Because what? Well, you're looking at these two sides. This one and this one. Yeah. So then if we look at 10, again we can set up our ratios. So is 6 over 3 equal to 7 over 4? So are those equal? No. It's because one of them, 6 over 3, we know 6 divided by 3 is 2, but 7 divided by 4 is not 2, so it's not parallel. Good. Questions?